It's Felipe here. So in this video, I'm going to change it up a little bit. I'm going to go into some coding stuff. So we're going to be basically learning about insertion sort and how to implement it and how it works, right? So basically, insertion sort is a sorting algorithm, right? It's used to sort things in an array or in a list in order from smallest to largest. So to kind of give you an idea visually how it looks, this is basically what it does, right? So it sorts things from smallest to greatest in a list or a data structure to ultimately at the end of the insertion sort, you got a sorted list, right? So this is basically what it does. It just organizes things in order, right? So basically, with insertion sort, you treat the first part of your list as sorted and the second part of your list is unsorted. Our algorithm will start by saying everything, the one index, so just index 0, the first elements. In computers, you start counting from 0, is sorted, and everything after unsorted. By definition, a list of 1 is already sorted because there's only one element in the list, so there's nothing else to sort, right? From there, we start with the next element in the list. In this case, the one index, the second element, and loop backwards over our sorted list, asking, is the element that I'm looking to insert larger than what's here? And if not, you work your way to the back of the array. If you land at the first element of the sorted part of the list, what you have is smaller than everything else, and you put it at the start. You then repeat this until you've done it over the whole list and you have an organized list, right? Or a sorted list. The mechanism by which we'll do this is that we'll keep moving bigger elements to the right by swapping items in the array or list as we move across the elements. When we come to a place where we're going to insert, we'll stop doing those swaps. So here we have an example of basically a list, right? Or an array. This list at the very top has the elements 3, 2, 5, 4, 1. So firstly, we move on to index 1, right? So index 1 is the number to be inserted. In this case, we ask the question, is 2 larger than 3? In this case, no, it's not. So we'll move 3 to the right. Beginning of the list, insert 2 at index 0, right? Then we move on to number 5, right? Which is the second element or second index 2, right? So is 5 larger than 3? Yes. It's already in the correct spot, so we leave it there. Then we move on to the next element, which is 4. Is 4 larger than 5? No, so move 5 to the right. Is 4 larger than 3? Yes, insert after 3 at index 2, right? Basically now we're at the end of the list. Is 1 larger than 5? No, move 5 to the right. Is 1 larger than 4? No, move 4 to the right. Is 1 larger than 3? No, move 3 to the right. Is 1 larger than 2? No, move 2 to the right. Beginning of the list, basically insert 1 at index 0, which is the first element in the list. At the end, we basically have a sorted list, right? What is the big O? The worst case scenario for this sort, a reverse sorted list. So basically a list that is large and not in order, and the algorithm would have to go through each element from the end of the array to the beginning of the array to sort it all out, right? And in this case, this would cause insertion sort to have a big O of n squared. What's the best scenario? In this case, basically, you have an already close to almost sorted list. And that would be the ideal use case for this algorithm. So in that case, it would be O of n. In this particular case, where you almost have an almost already sorted list, insertion sort would be better than using something like merge sort or quick sort, which are other algorithms that are actually a lot faster, right? So what is the average case of a randomly shuffled array? Well, it'll make a lot of comparisons and swaps, and those just grow exponentially as the array grows. So this would be O(n) squared. Not great for average use case, only used in nearly sorted situations. What about spatial complexity? It's O of 1. We don't create any additional items for this sort. So we're using the existing elements inside of the list or array and sorting those, not inserting any new additional elements, right? So the sort is destructive since we work on the array itself, and the sort can be stable as long as you program it so that they stay in order during the insertions. Great. So let's go ahead and see what this looks like, right? So let's actually write it in some code and see what it looks like. So I'm going to make a directory called insertion sorts, and I'm going to cd, so change directory into insertion sort. Then I'm going to npm init-y, so it doesn't ask me all those questions. Then I'm going to npm I, which is install nodemon packages. So get that going. Now I'm going to open this folder, right? So I'm going to open this folder, and first thing I'm going to do is add a script. So I'm just going to add a script here. Okay. And nodemon, I'll call the file insertion sorts.js, insertion sort.js, and I have to put mon over here, nodemon. Cool, save this, boom. And I'm just gonna create a file to write the code in, right? So it's gonna be called insertion sorts.js. There we go, boom. Go back into the editor. In this case, I'm using NeoVim. And let's start writing the actual code, right? So insertion sort, I'm gonna write a function, call it insertion sorts, and we'll pass in a list of numbers, right? So take one argument, nums, which will be a list of numbers. So let I equals 1, as long as I is less than that list that we passed in length. So the length of that list we passed in, we will increment I, right? So we'll do an additional iteration of I, right? So in this case, let number to insert equals nums I, right? Nums I, so the index of that current index of the list in this case, right? All right, cool. So I'm going to create a variable called j because we're going to use another loop. And interesting takeaway about this is when you have a loop inside of another loop, that usually is an indicator that is possibly a big O n squared, right? Which is not super fast for computers, right? It's not that great. So that kind of gives you an idea of what you kind of got going on. In this case, we have one loop that is nested inside of an outer loop, right? So that actually slows it down. So, okay, so let j equals I minus 1. So that would be the end of the list, right? So this loop will basically start at the end of the list while the other one starts at the beginning, right? So let's see here. Okay, as long as nums j it's larger than the number to insert, we will and of course j is greater than or equal to 0, because in that case, you know, you can just basically stop it, right? So we're going to decrement j. So then basically we're starting at the end of the list and working our way down to the beginning of the list in this case, right? So, all right, what we'll do here is basically nums j plus 1 equal, and close this off, plus 1 equals nums j. Cool. So close this loop off, right? Close that block off. And then here we'll do the actual insertion. So nums j plus 1 is going to equal that number to insert variable, right? So we'll close this outer loop out, and then we'll console.log nums, which is the list of numbers we're passing in, into the function, right? And then we're going to return that list, that organized list. All right, cool. So let me close the function off, and lastly, just create a variable called nums, and this is going to be the list, this organized list, right? 9, 8, 7, 6, 5, 4, 3, 2, 1. Great. So this would be basically what we're going to use to pass into that function, right? So we'll do an insertion sort call and pass in that variable, which is a list of numbers, right? Great. So I'm just going to save this. I don't have any syntax errors, so it should work. And over here, we're going to do npm start, and we should get a nums is not defined. So I made a little error here. So I'm just going to go back in really quickly. And vim dots. So nums is not defined, of course, because I have to return nums, not num. And resave this, exit again, clear all this junk, and do npm start again. And here we go, sweet. So now initially we fed the function a unordered list of numbers. And in this case, basically you can see that it spits out or returns that same list, but ordered, right? So, and initially it was 10 going all the way down to 1, and then it reversed it, right? Now it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 organized, right? So yeah, that's basically how insertion sort works. It's an algorithm to sort lists or data structures or whatever you need it to do in that sense, right? Cool. So with that, I'll leave you guys with a cool quote I recently came across and I love. And this is, software is eating the world. And that's super true. Everything these days is software, right? It's changed all businesses. It's changed the world, right? So software is definitely eating the world. Cool. So with that being said, if you guys liked what I shared and would like to see more, feel free to like and subscribe. I look forward to talking to you guys soon. Bye.